Now, in this lecture, we shall study geometry of PF5 molecule. Shape of PF5 molecule is trigonal bipyramidal. In PF5, central atom is phosphorus, which is having the configuration 1s2, 2s2, 2p6, 3s1, 3px1, 3py1, 3pz1, 3d1 in the excited state. It is able to make 5 bonds with the 5 fluorine atoms because of the presence of 5 unpaired electrons in its valence shell. In the formation of PF5, each of these electrons gets shared by 5 fluorine atoms. Because of this, the phosphorus atom gets surrounded by 5 bonded pair of electrons. You can see in this figure, total number of electrons present in the valence shell of phosphorus is equal to 5. Total number of bonds made by phosphorus is equal to 5. Total number of bond pair of electrons around phosphorus is equal to 5. Total number of unshared pair of electrons around phosphorus atom is equal to 0. In PF5, the central phosphorus atom has been bonded to 5 similar atoms by single covalent bonds and gets surrounded by only 5 shared pair of electrons. Therefore, PF5 should have regular geometry. However, actually the molecule is having irregular geometry. Now, explanation for irregular geometry. So as to attain maximum force of repulsion among 5 bonded electron pairs, 3 FPF bond angles would become 120 degree and 2 FPF bond angles would become 90 degree. The molecule gets trigonal bipyramidal geometry. In such geometry, the central atom is situated in the center of an equilateral triangle and 3 PF bonds, which are called equatorial bonds, gets directed towards the 3 corners of this triangle. Among the remaining 2 PF bonds called axial bonds, one is situated above and other below the trigonal plane and also perpendicular to it. Different bond lengths in equatorial and axial bonds. The bond length of equatorial bonds 2.04 angstrom has been found to be slightly less than axial bonds 2.19 angstrom. The reason is that each PF axial bond faces repulsion from 3 equatorial bonds at 90 degree and 1 axial bond at 180 degree to it, while each equatorial bond faces repulsion from 2 equatorial bonds at 120 degree to it and 2 axial bonds at 90 degree to it. Hence, each axial bond pair being nearer to 3 bond pairs at 90 degree has to face greater repulsion than PF equatorial bond pairs which are nearer to 2 bond pairs at 90 degree. In order to decrease repulsive force, axial bond pairs tend to move away from the central atom and the bond length of axial PF bonds gets increased. Because of the difference in bond length values of axial and equatorial bonds, the PF5 molecule is having irregular geometry. Unstability and more reactivity of PF5. The diagonal bipyramidal structure of PF5 has been an unsymmetrical structure. Because of this less stable unsymmetrical structure, PF5 has been highly reactive as compared to SF6 having symmetrical structure. Other examples of molecules including trigonal bipyramidal geometry include PCl5, SbCl5, etc. तो PF5 अणु में ट्राइगोनल बायपिरामिडल ज्योमेट्री पाई जाती है. sp3d हाइब्रिडाइजेशन है और इसमें 2 बॉन्ड एंगल्स हैं 90 डिग्री और 120 डिग्री. इसमें जो फ्लोरीन एटम्स जो कि इक्वेटोरियल पोजीशंस पर प्रेजेंट हैं उनके बीच में वो जो है 120 डिग्री का कोण बनाते हैं और जो 2 एक्सियल पोजीशन पर है वो 90 डिग्री का कोण बनाते हैं. नेक्स्ट लेक्चर में हम स्टडी करेंगे sp3d हाइब्रिडाइजेशन को ही स्टडी करेंगे, कैरी ऑन करेंगे. थैंक यू.